Okay, so the homework assignment, the questions at the bottom are going to involve working with arrays, matrices in Python. And what's really important is going to be to understand how these arrays are indexed, meaning how do we refer to the location of entries in a matrix. So one thing to be really careful about is Python is zero based. In other words, Python starts counting at 0, and then 1, and then 2, and then 3. Okay, as opposed to maybe how we might think of things as starting with 1, 2, 3, 4. So Python says 0, 1, 2, 3, 4. So let's consider the same matrix that we have up here. So I'm going to just print out this matrix down below. I'm going to add a block of R code. I hit the plus code, and my code is just A. Okay, so here's the matrix A that we're working with. And let's run this code below. So I can kind of indicate one particular entry in the matrix by adding square brackets after A. So my array was called A. And this is a two-dimensional array. So I can refer first to the row where this thing is living, and secondly, to the column where that entry is. So the very first entry in the very first row of this matrix, this number 1, we might say that it is in the first row, first column. That is true. It is the 1, 1 entry in this matrix. That's not how Python counts. Python says this is in the first row, which is row 0, and in the first column, which is column 0. So A11, we can kind of look at what comes out. So A00 tells me the first entry in the first row, first column. That's this one over here. If I want to get the next entry in the top row, A01 pulls off this 4. So now I'm still in row 0. So this is considered row 0. And now I'm in column 1. This is considered column 1. Again, because we start with 0. So just keep that in mind. If I want to get the second entry in column 2, that's a -1 over here. Notice I enter 1, meaning row 1, okay, which is actually row 2 for us. So the short story is we typically refer to things like in row I and column J. And if you want to get something from row I in column J of a matrix in Python, that means you actually want something in row I-1 and column J-1. So you're going to need to subtract 1 from the entry that you would typically refer to it as if you were calling it row 1, column 1. So that is how we can pull off a single entry from a matrix, right? I can identify specifically which row and which column it sits in, again, being mindful that these arrays start counting from 0, start indexing from 0. Sometimes we'll want to pull off several values from a row or from a column. And so we can use colon to slice off several consecutive values in a row or a column. And I think the best way to explain this is to just look at some examples. So I'm going to run this code down here. And so A0 over here means, okay, we're going to first look at row 0 in this array, okay, which means like row 1 for us, the top row of the matrix. And this 1 to 3 means we want to pull off all of the entries in row 0 over here, all of these entries, but we are going to start with entry 1. And so remember, this would be entry 0. Okay, I'm going to start with this is entry 1 in row 0. And we're going to include everything starting from that entry, which is over here, up to, okay, but not including 3. So this would be A0, 0. This is not included here. This would be A0, 1. So this is included. This is A0, 2. So that is also included. And this is A0, 3, which is not included. So this line over here is saying, go to row 0 and pick off entry 1 and 2, but stop before you get to 3. So really, it's just picking off the entries in what we would call column 2 and column 3. So that's where this 4 and this 3 come from. This line of code over here is doing something similar, but now we are fixing the column. So we're looking at column 2. So remember, this first thing is column 0, column 1. Here we are in column 2. And let's pick off entry 0. So that would be the 3. Entry 1, which is the -2. Entry 2, which is the 7. And we are going to stop and not include this entry over here. So in other words, this line of code over here gives me the 3, the -2, and the 7. And that we can see over here with the 3 and the -2 and the 7. So that's how we could slice, a series of values from an indicated row or from an indicated column. The last type of slicing that I want to talk about would be, what if we want to get everything in a row or everything in a column? We certainly can use the slicing that we talked about over here. For example, if I wanted to get everything in the top row, I could just type a 0 here for top row, and I could just start at 0, which would give me this one, and go from 0, 1, 2, 3, 4, and I would want to end it at 5. So let me copy that. So I could get the top row of matrix A by doing this. Okay, that pulls off the top row that we had over here. And recall that I need to start at 0 because we start counting at 0. It's 0, 1, 2, 3, 4, and I include 5 here because this means up to and include, but not including 5. So that's the top row. Since it might be annoying to try and count out, like, how many things do we have in the column, I could just indicate that with a colon and not indicate any start or end point. So that's going to tell me take everything in the top row. And we could similarly slice the entire columns. So if I want to get everything in the top row, I just type 0 and then I just say everything. That's what that colon is representing. If I want to get everything in the third column, then I would say, okay, column 3, that actually in Python means 3 minus 1, 2, that means column 2. And so if I want everything in column 2, then I just leave a colon for the row indicator. And you can check that here we're pulling off the first row, and here is everything that was in the third column, which again, we refer to in Python as column 2. I think that's the trickiest part about arrays in Python, is that the indexing starts at 0. So you've got some homework questions that are going to make sure that is clear with you. The last bit of linear algebra that I want to discuss that we can use Python for would be, how can we perform elementary row operations in Python? So recall that we've got 3 different types of elementary row operations: row replacement, interchanging rows, and scaling of a row. So here we're going to work with the following matrix B. And if you're curious about, hey, how did you make this matrix look so nice? This is a text block over here. So if you double click on that, you can see the LaTeX code that I used to get matrix B. So one elementary row operation is replacement. So for example, let's say I want to replace row 3 of matrix B, which is the last row over here. So when I talk about row 3, column 1, column 2, I'm not using Python language. I'm using how we describe it in words. And the only time you need to be careful about indexing from 0 is when we're typing Python code. So if I want to replace this third row in this matrix with -5 times the top row plus row 3, in other words, I want to do row reduction to get zeros beneath this pivot, here's how I could enter that replacement operation. I could do that calculation in Python. So first, we're going to be using the NumPy array. So I define this object B. I could call it whatever I like. And to B, I'm going to assign the array, which has the following 1, 2, 3 rows and 4 columns, right? So that comes from the matrix up top here. And what I'm going to do is replace row 3. And remember now that row 3 would have index 2. And I'm going to replace it with row 3 minus 5 times row 1. And recall that row 1 has index 0. And then I'm going to save this result as my new row 3. So let's go through what that code would look like. So down here, I've got B2, comma, colon. So remember, this means everything in row index 2, which for us actually means, physically speaking, the third row of the matrix. Okay, so we're going to redefine the third row of the matrix, which again has index 2. And we're going to redefine row 3 with the original value of row 3 minus 5 times the values in row 1, right? And remember, row 1 has an index of 0. So what this is going to do, it says, okay, we're going to redefine this third row. We're going to take -5 times the 1 and add it to the 5 that was down here. And I'm going to save that new result as the first entry in my new row 3. Then it's going to do the same operation. Let's multiply this -2 times -5. That gives me 10. We're going to add it to the value that was previously in row 3, which is 0. And that's now going to become the new entry in row 3. So this does it at once for everything in the row. And so now you can check the calculation down below. Should give us, great, we've got a 0 beneath that first pivot, and now this becomes 10, -10, and 10 over here. So that's how we can do replacement operations with Python. Interchanging 2 rows, that's another convenient operation. So keep in mind that after I've done this operation in the previous block of code, our matrix B is no longer what we started with. Okay, so we started with this array, and now the last row is no longer 5, 0, -5, 10, but now the last row is this. So just to be really clear, before I go into my next block of code, you can see that the matrix B has been saved as the output after doing this first replacement operation. So then I can go into the next block of code to do the next elementary row operation. So if I want to interchange rows 2 and 3 of matrix B, recall that row 2, well, that is going to have row index 1, and physically row 3 of matrix B is going to have row index 2. So I want to flip these two around. So I'm going to define row, what is now, index row 1 as previously what was row index 2. And I'm going to define row index 2 to be what was previously row index 1. So this is going to flip around row index 1 and row index 2, which happen to be rows 2 and 3 of the matrix. So now that just interchanged these last two rows. You can see now I've got 10 minus 10, that's become row 2, and 2 minus 8, 8. That is now my new row 3. So that's how we would interchange two rows. So hopefully you can kind of get the feel for how you could also interchange columns if you want to. That's not an elementary row operation, so you don't want to do that necessarily just yet. But you could play around with how would I interchange row 0 and, excuse me, the first row of the matrix and the second row of the matrix. Well, that would be interchanging row index 0 and row index 1. Okay, and then the third and final elementary row operation we've discussed is what's called the scaling of a row. And this one we get by just multiplying every entry of a specified row in the matrix by a specified constant. So if I want to make the output from the previous stage, let's say I want to make this pivot 1, I would need to scale row 2 by 1/10. And remember, row 2 of this matrix is going to have index 1, row index 1. So I'm going to go into my block of Python code down here. I'm going to choose row index 1, right, which means actually the second row of the matrix. And I'm going to take every entry in that row and divide it by 10. And that's the output from there. And we want to go ahead and keep on going through this row reduction process, going through Gaussian elimination. So the next thing that you would want to do would be to let's make every entry below the next pivot 0. So in other words, I want to replace row 3 with -2 times row 2 plus row 3. So that's this first operation here. We're going to replace row 3 with -2 times row 2 and add that to row 3. So row 3, right, has row index 2. We're going to subtract 2 times, okay, so I type that with the asterisk here, row 2. Okay, and so row 2 again has row index of 1. So that's why we have a 1 over here. So here I'm going to do a whole series of row operations at once. So you don't have to break this up into a bunch of different code blocks. So these operations here, you can kind of look at the code, make sure that it's doing the right thing, is going to take this matrix and complete the process of putting it into reduced row echelon form. And that looks great, right? We have pivot 1 for this column. We have a second pivot over here. We have a third pivot column over here. And then this column over here doesn't have a pivot in it. There are some weird formatting things that happen in Python, like it decides to write -0 as opposed to 0. But hopefully you're comfortable with thinking of -0 as the same thing as 0. And down below over here this is what it would look like if you wanted to do this whole series of row operations at once. Okay, and you can see how quickly it goes through and does those operations. And the last thing I want to mention before getting into the questions on your assignment would be an even faster way to get the reduced row echelon form. So somebody out there has written a nice algorithm for Gaussian elimination that is going to go through, that does all of the elementary row operations in the background. So you actually don't have to indicate which series of operations you want to use. Python is going to do this for you and output the reduced row echelon form, the equivalent reduced row echelon form, after doing those elementary row operations. So that function has a very special name. called matrix.rref. Okay, this means reduced row echelon form. Okay, this function, however, is not in the NumPy library. It's in a separate library that's called SymPy. And this is also available to us for free. So here are the two libraries that I need. I need NumPy to define arrays. And now I'm going to import SymPy because I want to use this super nice function that is built into the SymPy library. So I first load my matrix using the NumPy array. And then I'm going to use this SymPy library. So I need to indicate that this function matrix reduced row echelon form is not in NumPy. It's not in the base package of Python, but it's in this library called SymPy. So this means go into the SymPy library and pull off this function matrix reduced row echelon form. And there's only one input that goes into this function, which is the name where you've stored the array. So I stored the array into B. So if I run this line of code, it takes a little bit more time. It took almost a full second to do that, but it was performing a whole series of row operations. And notice we get the same exact matrix back that we got over here. Okay, so this is good. This checked our work, that our sequence of row operations did put this into the correct reduced row echelon form because this form is unique. So this function again is what's called matrix RREF. There's a dot that separates them. And the input here, the library where this lives is called SymPy. So that wraps up the introduction or kind of the content of this lab. And what's left is for you to answer some of the questions below. So I'm going to make one last video that's going to kind of indicate how you can enter your answers into this spreadsheet. And then again, how you would finally, or into this Google Colab document, and then how you could upload your work into Canvas.